What's poppin', dogs? Mr. Allen here with a wonderful application problem here. We're going to be pulling from multiple concepts of geometry here to find the measure of all these numbered angles on this rafter layout given a 9/12 pitch. First off, what in the heck is all that stuff? Well, a rafter is what frames your roof, all right, and the 9/12 pitch is the slope of your roof, the rise over the run. All right, so I'm going to draw up a nice little gable end roof so we can see what we're talking about here. All right, so just your classic, wonderful little house, right? You know, the first house you ever drew as a kid? Hey, that's a gable end roof. Now you know. All right, so my rise is 9 and my run is 12. That means for every 9 inches we go up, we're going 12 over, right? Okay, or 9 feet and 12 feet, or it could be like 4.5 feet up and 6 feet over, right? That is a ratio. That is the slope of our roof. But I can just call it the whole thing. So watch this. If I throw this guy a vertical line down here, I could say that's 9, and this right here is going to be 12. My rise is 9. My run is 12. And I got to figure out an angle here. Well, I can figure out this angle right here with a little inverse trigonometry. So I'm going to take the tangent inverse, right? I got my opposite side, and I've got my adjacent. That's why I picked tangent inverse. I have my opposite and my adjacent. That works with our tangent, right? If I had different sides, I'd be using a different trig function. And because I'm trying to find an angle, I'm going to be using inverse trig. All right, now time to bust out that TI. So we got second tangent to get tangent inverse, 9 divided by 12, and I'm going to get myself 36.869 degrees. Let's go with 36.9 degrees. Beautiful. Fantastic. All right. So now that I have one angle, what does that get me? Okay, what does that get me? Well, here's the tricky part about the visualization of this whole thing. This means that my roof is going up at a 36.9 degree angle. Okay. Now, in order to do that, my plumb cut of the rafter needs to be cut at that 36.9 degrees. That is angle 1. 36.9 degrees is going to be my angle 1 for this particular rafter, okay? Because that way, if I were to get this line, this purple solid line, which we're calling the plumb line, plumb being vertical, to get that vertical, I tilt that at 36.9 degrees. Now my roof slope is at 36.9. There we go. That's beautiful. You know what? I'm going to link in a dope TikTok I made a little while ago explaining how that works, why this is the angle off of that plumb line. All right, let us continue though. Now that I got that 36.9, I can figure out a lot of other angles, okay? Like for example, angle 2. This right here is gonna be 90 degrees, so angle 1 and angle 2 are gonna be complementary to each other. All right, now just to be safe, maybe we just plug these things in so we don't make some kind of silly mistake as we go through here. We're gonna get 53.1. Okay, 53.1 degrees for angle 2. Any others that might have that? About angle 3 right up here. Angle 2 and 3, those are alternate interior angles. My board edges are parallel to each other, hopefully, right? They should be. And this purple guy right here, my plumb cut, is going to be my transversal. 2 and 3 are alternate interior angles on that transversal and those two parallel lines. So they are congruent. We get 53.1 degrees. Woo! Beautiful. Can I figure out angle 4? Well, 3 and 4 should be supplementary, right? So 180 minus that 53.1 gives me 126.9 degrees. All right. We could do this in our head, but again, I want to be safe here. I don't want to make some silly mistake in the recordings, and then it's all over the YouTubes. And, no! Right? You know what I'm saying? So better safe than sorry. Okay. Cool. Beautiful. Wonderful. All right. What else we got here? Well, check this out. 2 and 5. This right here is going to be the same cut as this guy right here of my bird's mouth cut. That's what this is called, is bird's mouth cut. All right, this is the part that then sits on top of the wall. Again, pretty cool stuff with framing. If you don't know it all, it's okay, man. It's okay. Some dope stuff, though. Maybe I'll link some more things in there of cool videos. Okay, explaining what these parts are. So this purple line here is parallel to this guy right here. 2 and 5 are on the on the interior of those two parallel lines, and now the edge of my board is in fact the transversal. All right, so these are two same side interior angles, which means they are supplementary. So if angle 2 is 53.1, then angle 5 has to be that 126.9 degrees. Woo! Beautiful, wonderful, fantastic. All right, now how about 6? Well, 6 is going to be supplementary to 5. Also note that 2 and 6, those are corresponding angles, right? Parallel lines, transversal, they're in the same spot. 2 and 6 are corresponding angles, thus they are congruent. So 53.1 degrees. All right, how about 7? 7 and 6 are inside of this right triangle here, right? That better be a right angle. I did label it, but also should be implied that if it's a nice cut that's going to sit on a wall, it needs to be a right angle. So anyways, we got 90 degrees already taken care of. That means 90 degrees left for 6 and 7 in this thing here. So they're complementary to each other. Well, complementary to 53.1, we already know is 36.9. 36.9 degrees. All right. Beautiful. Wonderful. Fantastic. All right. How about number 8? Can we get number 8? Well, 8 and 7 are going to be supplementary to each other. So then we can take 180 minus that 36.9. And I'll get myself, whoops, I hit something weird. Hold up. 180 minus 36.9. I get 143.1 degrees. Lovely. Lovely. All right. We're almost done, man. We're 2/3 the way done. Nice. Little math. Little side math. All right. How about angle 9? Well, check this out. Check this out. 2 and 9. What's their relationship? This line here is going to be the same as that guy there as far as its angle. So they are parallel to each other. All right. This is my transversal. We're on the same side of that transversal. We're on the interior of those two parallel lines. Same side interior are supplementary. What is supplementary to angle 2? It's the same as what we had for angle 5, right? 2 and 5 are supplementary. So 126, for angle 9. 126.9 degrees. You can also see that with this guy right here and this one right here, 9 and 5 are corresponding angles. Might be a little harder to see, but they are indeed corresponding angles. They're in the same position. If I had two parallel lines like this, here is my 5, here is my 9. They are corresponding angles, all right? Cool. Awesome. I've said cool a lot, but it is cool, okay? All right, how about angle 10 here? Well, 9 and 10, parallel lines, transversal. Those are same side interior. A lot of same side interiors popping up in this rafter layout here. That's going to happen. All right. So 9 and 10 are supplementary. So what's supplementary to 9? Well, we know it's 53.1. So 53.1 degrees. 11 is going to be supplementary to 10. They're right next to each other. Straight line, hopefully. All right. Depending on where you get your lumber from. So we got 126.9 degrees. And then we got 12. That's going to be supplementary to that. All right. 9 and 12 are supplementary. Or you could say, 11 and 12. Those are same side interior angles. They're going to be supplementary. We get 53.1 degrees. So basically there's just like 4 angles that we're really working with throughout this here, but knowing which one goes where and making those connections to the, angle relationships we have with parallel lines and transversals, kind of a cool application of it. Something that I haven't always thought of until recently. There's just so much math and awesomeness built into a rafter layout, and changing that pitch changes all of these numbers right here, and you have to really think through that process. Hopefully you guys like it. If you've never seen roof framing or anything like that before, check out some of those links that I popped in this video. There's a lot of cool math that you can apply with framing, and especially framing roofs and all the rafters and cool things like that. All right, that's it. That's dope. That's awesome. You guys are awesome. I will see you dogs later. Deuces.